Rahim. We're going to start a new chapter, which is an important chapter in this course about data modeling using entity relationship or ER model. And if you remember what we said last time, we said we need to represent the data model, your design, you need to represent it for someone. For instance, if you are presenting something to someone who doesn't have any idea about database, who doesn't have the skills, or he doesn't know about the database. So after you do your design, you need to show that design in a model to facilitate the presentation of your database design. Okay, and it is that will include all those concepts that are related to the database will be shown in what is known as an entity relationship model, which is a popular high-level conceptual data model. We talk about conceptual data model. You're going to see later what is it. Okay. In terms of conceptual, just have a look at this diagram, which are, let's say, which shows the different steps of the database design process. Okay, this is a simplified overview. It's not the details, but it is, at least you do have an overview of how the database design process grow from one level to another level.
I'm sorry, Doctor.
In the first level,
I'm a student.
Shabab, don't interrupt me, please. Don't interrupt me during the lecture. Yes?
I'm sorry, but other doctor is another section.
Okay, you can go. Thank you very much.
Just tell the I student come there.
Okay, thank you very much. Thank you. Okay, we said that for the first step in the in this design is the requirement collection and analysis. Okay, now what do you think from in the requirement collection analysis? What will happen in this step? What do you do when you talk about the requirement and collection analysis? Yes, guys?
What do we do in requirements, you mean?
Yes.
We find out what the client needs and wants in the database.
Yes, good. Not missing this step, what you will do, you will just do some collection of information by interviewing, for instance, prospective database user, those who will use the database, okay, to understand exactly what they need, what are their requirements, because you are not going to create a database based on something that is not required by your client. Okay, you will interview, you do some interview, you do some questionnaire, for instance, and try to gather as much as information you can, okay, from those people who will be involved with the database, and analyze the database. Okay, analyze that what you have documented, what you have gathered as a requirement, as data. Okay, and you have to, for instance, write in a concise manner those requirements. You will say 1, 2, 3, 4, 5. This is what is needed. Okay, you're going to see in practice how you are going. You will face with requirement. Okay, in numerical format. For instance, I do have 1. I need this. 2. I need this. 3. I need this. Then you need to translate that or those requirements into another level. You will take those requirements into another level. Now, when we talk about the requirement, they should be specific, okay? And they should be specific, they should be detailed and complete as possible, okay? In the form as possible, because you need to not to miss anything. Otherwise, you will design your database, you will create database, and you will have something missing, okay? Something that you missed, and it is very important. It is needed by your client, okay? And it is not, you know, you spend time, you spend effort, you spend money to design the database, and at the end, when you need to, let's say, to release the product, you discover, no, I have forgotten some requirement. I didn't include them within the database. So you need to redo from the database again, and maybe you will be over the deadline, okay? And it costs you money because you have to do another effort. You have to ask people to redesign and so on. Okay? Specifically, if the design of the missing thing is related to orders. That means it needs to do the whole redesigning the database. Okay, the one that you have been working for months maybe, and you need to redo the job. That's why it is very important to do correctly this step. Okay, not to miss any requirement. Then once you are satisfied, the requirements are clear, you show them to the client. Is this what you need? He will say yes, nothing missing, nothing missing. They say, let's say let them to sign. Okay, so you start at that moment. You start by going to the next phase. Okay, so this is very important. And usually, okay, in parallel, what you can do, okay, in parallel, what you can do with specifying the data requirement, it is useful to specify, for instance, the non-functional requirement. Okay, what are non-functional requirements? As you are going to do in your project, functional and non-functional requirements. So you need to specify what are those functional requirements of the applications. Okay, and when you talk about functionalities, based on the user-defined operation, what are those operations? What are those transactions that need to be applied to the database? Okay, in terms of retrieval, what you are going to retrieve, what you are going to update. Okay, these are based on the functional
like the size of the database, مثلا?
Naam?
Like the size of the database?
Not the size database. We talk about operation, functional requirement. What is required as functions? What do you need as function? I need to read from the database. I need to update it. I need to delete. I need to be able to change. These are the functional functions.
Okay. And for example, the people who can edit the database, can be restricted. I forgot what it's called.
That's a non-functional. Maybe it can be in the non-functional thing. But here we talk about what are those actions, operations that it needs to be available. Let's imagine that you design an interface and it doesn't have a button for adding new customer to the database. It is missing because you didn't gather the functional requirement. If you gather functional requirement properly, you will know that you need to have an action, you need to have a transaction that will allow, for instance, the database administrator to add a new customer, for instance, to the database. Okay,
but
and all this
specifying the DBMS is also functional, or is it non-functional? Specifying the DBMS.
No, it is not now. Now it is not part of the process of collecting data. It is not part of the specifying the DBMS. Okay.
Okay.
So if the required, for instance, if the client will say, I need this DBMS and not this DBMS, that is part of the requirement, but you are not going to put it in the functional requirement. Functional requirement is what do you need to be available within your database? What actions, what transactions you want to do, you want to be able to do it on the database. Okay? Now, once the requirements have been collected, for instance, and analyzed, you will move to the next step. The next step, which is conceptual schema. Okay, when we talk about conceptual design, which leads us to the conceptual schema, we have already mentioned conceptual schema, which is high-level data model. Okay, or we can call it, it is called conceptual design. Okay, conceptual design or high-level data model. In this schema, okay, you will have a description of the data requirement, okay, of the user and include any descriptions. Okay, we're going to specify what are, for instance, the different types of entities, what are the relationships between those entities. If there are some constraints, you need to specify them. Some restrictions, you need to specify them. Okay, all this should be part of the conceptual design, which is based on from the requirement, you move on to this. It's like you are translating all the data you got, you translate it into conceptual design. Through conceptual design, I will say, I will have a student table, I will have course table, I do have a constraint that says the GPA should not exceed 4, for instance, or 5, or whatever, and so on. Okay, so this approach, when we do that high-level conceptual schema, okay, it is considered as that you show that the requirements are met, because it is the next phase of the requirement. After you do the requirement, you move on to the conceptual schema, you design, and through that conceptual schema or design, you show that all those requirements have been met. Okay, and this one, okay, sometimes you need to, for instance, here, as we mentioned, we are not worrying about the storage or how we do the implementation. The main thing in this step is to show the different components, the different constraints, relationships, entities that will be part of our database. Okay. Now, once you do that one, okay, you move on to the next phase or the next step in, let's say, which is the actual implementation. Okay, when I talk about the actual implementation, which is the logical design. Okay, when I talk about the logical design, is here we talk about using, for instance, a commercial DBMS to implement your design. Okay, here it was just a design. Now we move on to the implementation. Okay, we move on to the implementation. That means we are now going to create, okay, to create our database, that data model that was designed previously. It will be mapped to, for instance, something that is inside the computer, inside the DBMS. Okay, here we said it's just a croquette, for instance, or sketch of the design. But here we move on to the real thing. We translate that design into something real inside the computer. Okay? Then once you create your database, you created the tables, you move on to the next phase, which is the design phase or the physical design, where you specify the internal storage, okay, how your data will be stored, the structure of the files organizations, as we have mentioned in our previous chapter, the indexes, the access path, all those that are related to the physical design that is needed to show how the database will be structured and how the database or the data will be stored in a drive, for instance, or in a tape, or in USB, in the real world, in the physical world. Okay, and all this here we talk about a basic ER. This is an ER entity relationship diagram where you show, for instance, your database. These are what we have mentioned. Okay, as an example, okay, to show you a specific representation, we pick up a company database. Okay, and these are some requirements. Okay, you gathered, you ask, for instance, the peoples that were involved in that company, for instance, higher management, head of department, and so on, and you understood that you need to have in your company database, you need to have employees, you have department, you have projects, and the company is organized into department. Okay, it's like university, and in the department, each department controls a number of projects. Okay, and for the employee, you need to store for each employee his name, his social security number, his address, salary. You need to specify the gender and the birth date. And also what you need to keep track of the dependent of each employee, whether they do have children or not. These are the dependent. Okay, so this is, let's say, the requirement. This is what you need to reflect in your model for the company database. Okay, these are the requirements. Okay, 1, 2, 3, 4, 5. Okay, and we need to show those requirements. This is just simplified database. Okay, so basically what we do, this is the schematic or the ER diagram that will show, okay, all those requirements. Okay, we're going to study each part of this ER diagram, but as a general view, okay, this is the general view of the schema, the ER diagram schema for the company database with different notations. We have to respect some notations based on the ER, but just for the sake of, let's say, as a requirement, we said we need to have employees, department, and project. Okay, if you can see here, I do have here employees, I do have here department, I do have a project. Okay, we show that means in our diagram we have put those entities that are required by the company database. We said the department controls a number of projects. Okay, if we go to the department, we said that department controls, okay, project. We have mentioned that in our diagram. We say the employee has name, social security. These are the attributes. Okay, and we showed them employee. This is the social security number, birth date, middle name, first name, name, last name, address, salary, and his sex or the gender. Okay, you keep track of the dependent for each employee, whether that employee has children or not. So if you can see here, we do have employee and we do have here dependent. Okay, some relationship that we specify the dependent for each employee. I will say this employee with SSN or social security number 1, 2, 3 has the dependent with the name, sex, birthday, and the relationship, whether he is a son or daughter, for instance. Okay, if you can see here, these are the requirements. Okay, and we reflected, we showed those requirements in our diagram. This is an ER, simplified the ER diagram. Okay, and you can present the design or the whole design. Here I have only 5 statements or 5 requirements. We might have a list, a long list of requirements, and you need to show those requirements in an ER diagram or model. This is what we mean by a model, ER diagram model.
Doctor?
Yes, Shabab. Don't worry about the notation. We said we are going to study the ER on its own. Now, my main thing is to understand the concept. There are some concepts that are inside here, so we need to understand the concept. The notations will come later, inshallah. Yes?
Doctor, should each single requirement be reflected upon the ER diagram?
Yes. Every single requirement should be reflected in the ER diagram, because from this ER diagram, you will translate it into a logical design. Okay, you will go to the logical design. From the conceptual design here, we are using our model. We're going to move it into logical design, something that will be created in a computer base. So it is very important to have all those, that ER model should be done correctly. And we will have another chapter, inshallah, that will show you how to translate this diagram into something that is related to the entities and the relationships. Okay, Shabab?
Is this possible with very large databases and projects?
Yes, of course, yes. You have to show it. Yeah, there are tools. We are not going to do it on your by hand. Okay, there are some tools that will help you to design and correctly show those relationships. Of course, if it is complicated, if it is complicated, for instance, you might divide it. Okay, but you have to put a link. Okay, you have to put a link between the ER, because if it is complicated, for instance, I do have another part that will involve the employee with another many things there. So you will just put here, for instance, something like square, and that square will be detailed in another ER diagram, more detailed. But at the end, you should have that ER diagram model. Okay, to understand your concept and to look at your design. This is the way how you do your design. It's like you are doing programming. Okay, when you do programming, you start by writing your code in a draft. Okay, and you will see whether you do have some errors or not, whether you are following some logic or not. And this is the way how to verify. How can you verify all those statements? We will go through each one. I will go to this first one, and I will see whether I have represented that one. I will go to the second one. Has this one has been represented and how? So I will see how it was represented and so on. Okay, Shabab? And as we mentioned in the entity relationship model, we describe what? We describe entities, we describe relationships, and we describe the attributes. Okay? When we talk here about entities, these are the entity: employee entity, department entity, project entity, dependent entity. Okay, relationship, this is the relationship between employee and the department. Relationship between department entity and project, it is done through this relationship. Okay, the thing that will let us link the department table to the project table through a relationship that we called controls. Okay, I do have here employee with a dependent, through which relationship they have been linked together through dependence of relationship. Okay, this is what we mean by relationships. Attribute, as we mentioned, attribute, employee has this as attribute, salary, address, whatever. Department has this attribute, name, location, number. Okay, dependent has this attribute, name, sex, birthday, relationship. So these are the attribute. Okay, and we have already defined the entity. We said the entity is something that is taken from the real world with independent existence. That means the employee, those people who are employees exist. Whether the department exists or not, they are human, they are persons, they exist in the real world. Okay, they are independent. The department is independent of the employee. Project is independent of the employee, and so on. And attribute, as we mentioned, for the attribute, we do have those properties that will describe your entity. Okay, to describe the attribute, for instance, for that particular entity, as we mentioned, to describe the employee entity, okay, we need to add some types of characteristics for that employee entity, which we call attribute. Okay, and the attribute of value, the value for the attribute for each entity is a very important, let's say, description or characteristic of that entity within the database. Okay, when we say that a student has student ID, mobile phone, address, courses taken, for instance, GPA, these are the very important attribute or characteristic for such student that will be reflected and created inside the database. Okay, and we do have, this is an example of, for instance, an employee E1. Okay, it's like, and I do have another company C1. This is an entity, and this is an entity. This is just an element of that entity. Here we said I do have employee entity, and just imagine that employee entity, it's like a set, مجموعة, and that employee entity has employees. Okay, فيها موظفين. It does have entity 1, employee 1, employee 2, employee Muhammad, Ali, Ahmed, Omar, Laith, whatever. These are the employees inside the employee table or employee entity. Here what we are doing here in our diagram, we are showing the entities. We are not showing the data. We are saying this is the structure of our database. These are the different parts that will be available in our database, with each part that does have attributes, relationship, and so on. Okay, and this is an example of a real employee. If we pick up E1, this is an element of the employee entity. What information that employee has? He has these attributes: name, address, age, home phone, and we do have his exact data. These are the values for the name. Value for the name. This is the value for the address. This is the value for his age. If I go to the company database, okay, if I do have a company, okay, what I will do, I will have for the company, I will have, for instance, name, headquarters, president, for instance. This is another example. Okay, and I will have, this is an element, okay, an element of the company entity with the different attributes, and these are the values of the attribute. Okay, Shabab? Now, for those attributes, okay, we do have different types of attribute. We can have a composite attribute. We can have a simple attribute. We can have single valued attribute. We can have multi-valued attribute. We can have a stored attribute. We can have a derived attribute, null value attribute, a complex attribute. Okay, these are known as the different types of attribute. For the composite attribute, we said that we can have a simple can be divided, those composite attributes can be divided into smaller part, okay, which represent those basic attributes. Okay, for instance, if I go to the address attribute, for instance, you go to the address attribute, and we do find that the address attribute is divided into different types of, see here. Okay, for instance, this is a composite one. Locations, for instance, locations. Okay, here for the address, it is direct one. But let's pick up, for instance, if we go to our example, yes, this address, for instance. If you can see here the address, it does have many parts. Okay, you can have in your address your flat number. You might have the address, the street name. You might have the city. You might have a zip code, maybe PO box, for instance. These are the different types or different part of, let's say, the address attribute. That means that address attribute has been divided into a smaller part, which are known as, let's say, which is this attribute is known as a composite. That means it is made up of, okay, street number, flat number, street name, zip code, and city. This is what makes your address. Okay, we call it a composite. Or you can have a simple one, atomic simple one. That means it is not divided. Okay, it is a simple one that are not divisible. Okay, I do have an address is one string, one bigger string that will include all those parts. Okay, as I can have, that address might be divided into different parts. Okay, this is what is known as a composite. We might have, it's like here, for instance, I don't know if you do have it here. Yes, here it is. Okay, when you do have a composite, I do have the address, and the address is divided into sub information or sub categories. In the address, I do have street address, city, state, and zip. And also that street address is itself is divided. It is a composite of number, street, and apartment number. Okay, this is an example of a composite attribute. Okay, that means it is not atomic, it is not one shot. Okay, if I said atomic, that means the address is not divided into this small smaller part. It is one part. Okay, but when we said it is composite, that means it is divided into smaller part, and you have to specify those smaller or composite attribute. Okay, Shabab? We can have a single attribute value, or we can have a multi-valued attribute. Okay, usually when we talk about an attribute, most of the attributes have a single value. For specific, for instance, an entity. If you do have a single value that will accept only one value, we say that attribute is a single value. For instance, for the age, if you go to the age of someone, or let's say birth date. Okay, how many birth date we can have for an employee? You can have only one birthday. Okay, age, if you did have age as an attribute, we can have only one value. We cannot say this employee is 25 years old and he is 35. Okay, he has only one value. That attribute will accept only one value. In that case, we say that attribute is known as a single value. Some attributes are considered or accept to have more than one value. We call them multi-valued. For instance, someone who has a degree. Okay, you have inside your attribute something that is called degrees. You can find an employee who has many degrees. Okay, he has PhD, he has master, he has BSc. So that means that attribute will contain more than one value. Okay, that means he does have more than one degree. This type of attribute is known as a multi-valued attribute. Okay, Shabab? Okay, till now? Yes?
Clear.
Okay.
Yes.
We do have a stored and derived. We have already spoke about the stored and derived. Okay, something that is stored attribute. That means it is inside the database. Okay, it has been created. It has been created in the database. Okay, and the derive, something that you derive. Okay, for instance, in the employee, okay, the number of employees for the department, it is not part, it is not an attribute of that department, but you can derive it. Okay, you will just look at the employee, you count the number of employees who works for the department, and you will have such information, which is the number of employees of that let's say, computer science department. However, that number of employees, it is not an attribute of the department. It is derived. And if you remember, we gave the example of age. Okay, age. What we store in the database, we store the birth date. We are not storing the age attribute. But that age, we can derive it. We can conclude what is the age of the employee based on the birth date, for instance. Okay, Shabab?
Doctor,
Okay.
Yes?
why don't we store the number of employees? Isn't it important?
It is not important. It's you know, as much as you can, for instance, that you restrict the attribute, you make your database simple. Okay, something that is not needed, for instance, from the requirement, you don't need to know the number of to store, not to know, to store that information. But we need it. What we can do, we can write some small routines that will calculate the number of compare based on, for instance, when you query, you will get that information just through querying, through SQL command. You can get such information. So you know, because when you add an attribute to your an extra attribute, that means that attribute has a data type, and the data type will have some size in memory. That means you are taking part of your memory. Okay, and here we are talking not only imagine that you do have 1,000 employee. That means for each employee you will have, or let's say you do have 100 department, and for each department you will have a field and in memory, or a space on address space in memory that is reserved for the number of employee. Okay, you are consuming the memory. Even for the search, when you do search, you have to go through all those fields. Okay, and what you try to do when you do your design, you try to minimize, okay, the number of attributes, the number of entities, in order to make your database concise, and it is quicker to search within and go through it and so on. Yes. Okay.
Okay, thank you, Doctor.
You're welcome. Null value. What is meant by an attribute that does have a null value? That means, for instance, some attribute may not have an applicable value for specific attribute. Okay, sometimes some attribute, they don't have a value for that specific attribute. For instance, let's say you are living in a villa, for instance. Okay, and you put within your address, in the address, for instance, you put, let's say, apartment number. Okay? Apartment number will be applied where? When you do have a building and you do have many apartments. I have apartment number 1, 2, 3, and so on. But when you live in a villa, if your address is a villa, for instance, we don't have apartment number. That means in that field, I will put null. That means it doesn't apply. Okay, Shabab? Clear for that null value?
Okay.
And we can have a complex attribute. We can have a complex attribute. Sometimes, in general, composite and multi-valued attribute can be nested together, where we said it is a complex attribute. Okay, it is complex attribute. That means you have, I don't know to have it here. Yes, here it is. Okay, complex attribute. That means you will have nested something inside something. Okay, you do have composite and multi-valued attribute. Okay, I do have address phone. It is composed of phone address, yes, phone address and city, and that phone is made up of area code, phone number, the address is made up of street address. So you have nested, okay, something inside something else. Okay, here we said that we do have a complex attribute where we do have composite and multi-valued. Together, they are concatenated, or they are nested inside each other in one attribute, and that attribute is called complex attribute. Okay, guys? So this is for 2 days. So we stop for 2 days.